The people who make this test are well aware of common math errors, and they prey on them by specifically designing questions that cause you to make mistakes, and then, more dangerously, answer choices that keep you from realizing you made a mistake in the first place. I'm Erika with Target Test Prep, and today I want to share 16 rapid-fire careless errors that test takers make all the time in GMAT Math, as well as how you can avoid these silly mistakes. Let's jump in. Silly GMAT Math mistake number 1 is distribution errors. This is just for distributing multiplication. We'll talk about distributing division as well as exponents and roots later in the video. Everyone knows that when multiplying polynomials, you need to multiply each term in the first polynomial by each term in the second polynomial. It is basic algebra. However, it is extremely common to accidentally skip a term or part of a term, the sign, the coefficient, the exponent, etc. The best way to avoid this error is with rigorous scratch work. If it isn't written out, write it out. If you don't have parentheses, add them. Circle terms with negative signs so you don't forget to include them when multiplying. Draw a loop between each set of terms as you multiply them to ensure that you took care of every necessary combination. Use FOIL if relevant, or go in order, one term at a time. And then do a quick logical check at the end to ensure you ended up with the correct number of terms and the correct sign on each one. And remember, distributing a negative is the same thing as multiplying by -1 and is an extremely common source of distribution errors. Take your time to do it correctly. Careless math error number 2 is the factoring error. This is basically the inverse of the distribution error. But while distribution errors can be mitigated with scratch work, a lot of factoring involves work in your head, which is significantly more error-prone. The biggest trick here is actually the same as the last, distribute, but this time as a check on your factoring work. When you redistribute your factored expression, you should get the expanded expression you started with. If you don't, you made a mistake somewhere. When factoring out a binomial, I'd recommend writing this out, but for factoring out a single term, I find a mental logical check often suffices. If I distribute, would I get the right sign on each term? How about the right coefficients and exponents? And would I get the correct number of terms? And importantly, when you factor out the full value of a term, it's going to leave behind a plus or minus 1. It does not disappear completely. Incredibly common version of this mistake. Next up is incorrectly doing the same thing to both sides. Doing the same thing to both sides is our number 1 tool for equations. We use it literally all the time, but because we use it so frequently, it's common that we get complacent and sloppy while we're doing it. Multiplying or dividing both sides can, of course, yield distribution errors, but we also frequently see forgetting to do the second side altogether. There is a simple fix for this one. Don't try to do too many operations at once, especially in your head. Write out the operation you're doing twice, once on each side of the equation, and then execute it in the following line of math. Our 4th silly mistake is neglecting to flip inequalities. By and large, we treat inequalities the same way we treat equations, manipulating them by doing the same thing to both sides. However, there is one key difference. When we multiply or divide an inequality by a negative number, we need to flip the sign. Forgetting to do this completely changes the math and will give us a wrong answer the vast majority of the time. The solution you get when you make this mistake is pretty much guaranteed to be one of the wrong answer choices, so you want this to be top of mind going into test day. In your practice, rehearse stopping when you encounter an inequalities problem, reminding yourself of the impact of negatives, and only then moving ahead with your math. Our 5th careless error is forgetting how fractions work. When we have addition or subtraction in the numerator of a fraction, we can distribute the denominator across the terms in the numerator, creating multiple fractions with the same denominator. This is true. However, the inverse is not true. We cannot split a denominator with multiple terms into multiple fractions. Whether this one shows up in the wrong answer choices is going to depend on the problem, but best case scenario, you still end up wasting a ton of time. The best way to avoid this one is by practicing doing it right until it becomes a habit. But if you know you're prone to this mistake, like with factoring, you can check your math by working backwards. It should hopefully be quickly apparent that you can't easily add 2 fractions with different denominators, which should clue you in that something in your math went wrong. Error number 6, ignoring order of operations. The issue here is typically with implicit multiplication and exponents, like a negative in front of a number with an exponent, or a coefficient in front of a variable with an exponent. The negative and the coefficient both represent multiplication operations, and thus should happen after the exponent is handled, and thus the exponent should not apply to them. A good move here is essentially the opposite of the circle trick. Rather than putting a circle that visually groups a negative in with a coefficient or a coefficient in with a variable, here we add parentheses that do not include anything that isn't immediately next to the exponent. This again helps us when calculating to intentionally leave out anything that the exponent doesn't apply to. And remember, it isn't really PEMDAS and BODMAS, it's PEMD as and BODM as. Multiplication is just division by a fraction, so they are equivalent and should be executed from left to right. Similarly, subtraction is just adding a negative, so they are the same and should be executed again from left to right. Mistake number 7, misapplication of exponent rules. To be clear, this is not about not knowing your exponent rules. That's a mistake, but not a careless one. No, the most common way that test takers mess up exponent rules goes back to basic distribution. Test takers incorrectly apply exponents to individual terms in an expression rather than applying them to the expression as a whole and then correctly distributing multiplication of each term. The move here is to write out exponentiation of anything with more than one term as multiplication with parentheses. And then again, draw your little loops to stay as organized as possible as you distribute. And importantly, roots are just fractional exponents, so you also cannot distribute a root across multiple terms. You're probably going to want to manipulate to get rid of the root instead. The hard problem in my 3 levels of exponents and roots video features this concept, so I recommend checking that out after this video. Next up is dropping a negative. This one is so annoying. It's happened to me multiple times. Negatives have a habit of disappearing from your work, and not just when distributing. I find especially that negatives at the very beginning of an expression tend not to make it to the next line of work, and by the time you realize something is wrong, you've wasted a ton of time doing incorrect math. This is a tough one to avoid. My best tips here are to make sure your negatives live close to your terms versus out in space where you're likely to overlook them. And if you notice a negative at the beginning of an expression, once again, use the circle trick as a visual cue that they go together. Following on from the last one is dropping a term. This is the last mistake on steroids. When you're doing a lot of work with a lot of terms, it's easy for one to get lost in the shuffle, again, completely derailing your math and wasting your time. Prevention is worth a pound of cure here. Check your work when manipulating polynomials and try to vertically align your math such that you can track your term down the lines of work and make sure it hasn't disappeared when it shouldn't. Silly mistake number 10 is dividing by unknown variables. A lot of test takers don't even know that this is an error, and those that do, forget about it. When we're manipulating an equation, we need to be extremely careful when dividing by an unknown variable if that variable could possibly be 0, as dividing by 0 can completely break our equation and give us an invalid answer. This is also true when manipulating inequalities if the variable we're dividing by could be either negative or positive because, as we know, a negative variable would flip the sign while a positive variable wouldn't. So if we don't know whether our variable is positive or negative, we don't know what to do with the sign and run the risk of doing the wrong thing. Now, of course, many such questions will specify in the question stem that your variable cannot equal 0 or that it is either positive or negative, in which case you can move forward confidently with your math. But it's important to have an alarm bell set in your mind for any time you're dividing by a variable to confirm that you can, in fact, do that. Which leads us to careless error number 11, not checking for extraneous solutions. Many students forget about the existence of extraneous solutions. Because of the way denominators interact with zeros, as in the last mistake, as well as the way absolute values and roots interact with negative numbers, manipulating equations with these elements can introduce solutions that don't work in the original equation. This means that we need to plug our solutions back into the original equation to confirm that they do in fact satisfy it. But it's easy to neglect to do this when it's the last step, and we see those solutions in the wrong answer choices. Again, awareness is a huge part of addressing this one. Similar to the last one, a good move is to jot a note to yourself in your scratch work at the beginning of the problem when you notice a variable in a denominator, an absolute value, or a root. This gives you a better shot at remembering to confirm your solutions later in the problem when you're more distracted. Mistake number 12 is not calculating your total. This is a classic in ratios, proportions, and percents. Many of these questions will ask you to calculate sum total by adding up some values and then find the percent or proportion one of those values is of that total. But test takers will often mistakenly take the percent or proportion that value is of another value and never calculate the total at all. This shows up in wrong answer choices all the time, so it's important to be aware of. A helpful strategy is at the beginning of the problem to write out what you're solving for, expressing the total as the sum of its parts. If you don't have values, you can use words or define variables as needed. This will ensure you actually execute this calculation later in the problem when you're more likely to have forgotten that you still need to do it. Error number 13 is the Fencepost error. This error occurs when calculating the number of things in between two of those things. This could be a word problem, calculating the number of fence posts in a fence, hence the name, or it could be calculating the number of integers or the number of multiples of a certain value in between two numbers. The trick with these is that if you want to include the ends in your total, you need to add 1. If you don't want to include the ends, you need to subtract 1. Fencepost errors will almost certainly show up in the wrong answers on relevant problems, so this is yet another one you need to bear in mind when you identify the problem type. Next up is stopping a step short. This one is insidious. Test takers get so excited that they've solved for something that they don't realize that what they have in front of them is actually an intermediate solution and not what the question's asking for. Usually when this happens, they're just one step off from the correct answer. They solved for x instead of y, they solved for x instead of x squared. And of course, the intermediate solution is almost always represented in the wrong answer choices. To avoid this, always check the question target before submitting to make sure you solved for the right thing. And this is easiest if you have written down what it is that you're solving for, which is why that is my number 1 math tip. Check out my video for more on that. Our 15th silly mistake is underutilizing given information. This is super similar to the last one. Test takers get so excited to get to solving that they breeze over a key piece of information from the question stem. Often this is something small but critical, words like non-negative or integer, identities like x is greater than 1. This information can shape how we solve the problem from the start, or more frequently can lead to a final step in solving that, as in the last mistake, test takers often skip. To avoid this, take your time interpreting the question stem, processing one piece of information at a time, and writing important details down to refer back to later and to cement them in your mind. Our 16th and final careless error is the classic mental math mistake. Super straightforward, super easy to make. I literally made a mental math error myself in a recent video, and I've done this for a living for over a decade, so we all fall victim here. But nonetheless, there are some best practices that can help you out here, primarily not trying to hold more than one piece of information in your head at a time, and doing a logical check on your math, typically using estimation, to determine whether the value or term you came up with actually makes sense. Let us know in the comments if there's a careless mistake you make that we didn't include in this video. And be sure to like and subscribe for more videos from me every Wednesday. Thanks for watching, and I'll see you in the next one.